Hi everyone, and welcome to the talk titled Optimize Your Development Workflow with NX Cloud. I'm excited to be sharing this talk here today at Conf with you. So, as you might have guessed from the title, we're going to be talking about NX Cloud and how its features help you in your day-to-day development. One thing to note is that in order for us to focus on features of NX Cloud, this talk assumes some basic familiarity with NX itself. But at the same time, you don't have to have a ton of experience with it. Just knowing some basic commands is absolutely fine. Besides, I'll be talking through some of the more intricate details of NX Cloud as we come across them in this talk. And just before we start talking about NX Cloud itself, let me briefly introduce myself. So my name is Kirils, and I'm a software engineer at Nrwl, the company behind NX and as well as NX Cloud. And you can find me by my handle at Kirjai, both on GitHub and on Twitter. All right, now let's talk about NX Cloud. So the first question that you might have is what NX Cloud actually is. Well, it's a product that we offer at Nrwl, and it's meant to be used in conjunction with NX, since it adds some features and some additional functionality on top of your NX workspaces. So in fact, those of you who've tried out NX before, you've probably seen the following prompt. So when you're creating a brand new workspace, NX workspace that is, with the create NX workspace command, at a certain point during the process, NX asks you whether you'd like to enable NX Cloud in this new workspace. And by enabling NX Cloud, you can enjoy such benefits like faster builds, run details, GitHub integration, and more. And so we'll be diving into the specific features of NX Cloud that enable these great benefits. So the three big features that we're going to be talking about today in this talk are going to be distributed caching, distributed task execution, and the final feature, insights and run details. Now, it's worth mentioning that those aren't the only feature of NX Cloud, but the three that we're going to be covering in this talk here today. And so let's dive right into the first one, and that is distributed cache. But actually, just before we dive into distributed cache that is offered by NX Cloud, let's briefly talk about caching in NX more generally. Hopefully most users of NX are aware that NX comes with some caching capabilities out of the box, and you might sometimes see it referred to as local caching. So let's take a look at an example of that briefly. So here I have a workspace, a brand new NX workspace with a couple of applications and some libs. And one of the applications that I have here is an application called admin. So if I, for example, run the build against the admin application, that will take a few seconds to actually run and complete. Because it's a pretty small application, it shouldn't take too long. It should take a few seconds, and there it is. So we can see that there's a successful terminal output since I ran the command, and we can see that the dist directory has been created with the build artifacts for our application. And now if I rerun the same command again, without changing the command or the source code, we can see that it completed pretty much instantly. And we still, again, see the actual terminal output. But at the very bottom, it also says that NX read the output from cache instead of running the command for 1 out of 1 tasks. So this suggests that it took the command from cache. It took the result of the command of the build from cache. And since we already see that the terminal output is already printed, we can also see that in action if we completely delete the dist directory and we rerun the build. Once again, completes super fast because it's read it from cache. And we can see that the dist directory has been added and populated with the build artifacts again. So that's the basic NX cache that you get from NX out of the box. You don't need to use NX Cloud, have it enabled, disabled, doesn't matter. This is the caching that you get out of the box anyway. So hopefully for those that are already using NX, hopefully you've already seen how NX local cache can be helpful and can save you some time as you're developing in your day-to-day life. So visualizing this local cache functionality, we have a single developer both populating and reading from the cache on their machine. And so when we add a second developer into this picture, they also have their own cache instance that's once again local to their machine. And that actually right there exposes the somewhat glaring limitation of local cache, and that this cache is local. So what happens on one developer's machine doesn't benefit other developers in your team and your organization. And in fact, the default location for NX local cache is in node modules of your project. So as soon as you delete node modules, again, on your machine, that local cache is now empty and will need to be repopulated as you start running commands, NX commands. And that's actually where the distributed cache from NX Cloud comes into play. So going back to our example of the two developers from earlier for a second, where they're both working with their local cache instances. And let's introduce distributed cache from NX Cloud into the picture. So what actually happens, now that we've added distributed cache, is that each developer's local cache is taken by NX Cloud's distributed cache, and NX Cloud makes it available for other developers in your organization and your team. So distributed caching essentially makes the caching that you get with NX even more useful and more widely available across your organization. Simply put, it adds another layer on top of your local cache. What that means in practice, though, is that let's say we have, once again, two developers, and they both pull the latest main branch in their repo. And as soon as one of them runs the build of an application in that workspace, for example, once again, admin application, once that build finishes and succeeds on the first developer's machine, running the same command on another developer's machine will succeed almost instantly, as we've just seen with local cache. And that is obviously even though developer 2 has never run the build on their machine before since pulling the latest master. So what actually happens is that NX won't actually run the build for the second developer because it will simply pull the results out of the successful build that developer 1 has already run on their machine from distributed cache. And this, of course, is true if the source code and the command that the two developers run are identical. So as soon as you add additional flags to the command or change the source code of the project that you're running the command against, that will actually still run the build rather than pulling it from cache. But actually developers on your team and in your organization that are working on the same NX workspace aren't the only consumers of the distributed cache. In my opinion, distributed caching is also a great fit for CI. And to demonstrate the benefits of distributed caching on CI, let's look at the example of opening a pull request in an NX workspace GitHub repo. So going through that example, let's assume we have a Git tree, so represented here on the slide. And you've got your main branch on the left in light blue and your pull request branch in the right in purple. And each circle in the tree represents a commit. What we also have here is a dependency tree, dependency graph, of an NX workspace that we'll be using as the example. So let's say at a certain point you branch off, and that's that purple commit, purple circle, and you push commit to your pull request branch. And let's say that in that commit, you've made changes to two libraries, feature filter and feature users. In doing that, there are now 3 affected projects in your workspace, the 2 libraries that have been changed, as well as the admin application since it depends on the changed libraries. So you've made those changes, and let's say you're happy with the introduced changes and you're ready to open a pull request. At the same time, let's also assume that your pull request CI workflow looks something like this. And this specific provider we'll be using here is GitHub Actions, but the same works with pretty much any other CI provider as well. So hopefully this example is simple enough to understand what's actually going on without knowing the specific syntax of GitHub Actions. But the most important lines are the 3 lines at the bottom. And here we're essentially saying that we want to build, lint, and test only the affected projects in our NX workspace. That's what we want to do whenever a new pull request is added or submitted, is opened in our NX workspace GitHub repo. So let's see what running that CI workflow that we've just seen in response to us opening a PR with the affected project, with the 3 affected projects actually looks like. And if we go to the GitHub, we'll see that after some time, when CI workflow has actually run, we see that it completed all the tasks that we asked it to complete. So we have the build, the lint, and the test. And for example, if we look at the tests, we can see here a log from NX saying that running target test was done for 3 projects: feature filter, admin, feature users. And those are exactly the 3 projects that we've identified before as being affected by the changes. So we can see that all the tests have run for those 3 applications and it succeeded. So going back to the slides. Now, let's say we've opened up pull request, and now let's say we've received some feedback on our pull request, and we need to make some further changes. However, we only need to change the feature users library this time without actually making changes to feature filter. And as a result of that change, we would be affecting 2 projects now instead of the 3 that we affected in the first commit on our pull request. So we're affecting the feature users because that's where we created and made the change. And we're also affecting the admin application because it depends on the feature users once again. So we go ahead, make the required change, and push another commit to our PR branch. And now let's see what happens on CI in response to this new commit that we've just pushed. So once we push that second commit, we once again see that the CI has run. Hopefully once again it succeeds. And once again it ran the build, the lint, and the test. And going back to our test example, we see that once again, NX has identified that 3 projects have been affected. And the reason it's 3, as it was the last time, and not 2, is because our CI workflow checks all commits in a pull request, not just the most recent one. So we still are checking the previous commit. We're checking which projects were affected by both the first and the second commit at the same time. And obviously, for us, that's 3 projects. So 3 projects is correct, and that's what we would expect to see. So, however, if we look at the actual output towards the bottom, we'll see that NX retrieved results for one of the projects from cache. And just below that, we see that the cached project is actually feature filter. And that's exactly the project that we haven't changed in our most recent commit, but we've changed in the first commit. So now why would that result of the project will be retrieved from cache? Well, it's because we haven't made changes to feature filter after the last time the tests were run. So remember that caching works when an identical command is run on the identical source code. So when we pushed the first commit in our pull request, the tests were run for all 3 projects, as we've just seen. Then, when we made changes only to the feature users library and pushed the second commit, the source code for feature filter hasn't changed. Therefore, the result of running that project's test can be safely retrieved from cache. And the reason it ran this the feature filter test in the first place is because it's affected by our previous changes, by the previous changes introduced in this pull request altogether. So hopefully that makes sense. So now this might not seem like a big deal, but this is a game changer for larger workspaces. As the larger the workspace, the more time is being saved with distributed caching. So such use cases like we just highlighted just now, like pushing additional commits on a pull request branch, really start adding up quite fast. And it can result in great amount of time saved the longer you have this feature enabled, obviously, before. So essentially, distributed cache allows you to never build, test, lint, etc. the same code twice. And you would be surprised how often the same code is being verified and built within an organization. So keep in mind that we've only covered the example of opening a pull request. For example, it is common to also run code quality checks on every push to the main branch. And since often pushes to main occur when a pull request is merged, the code quality checks on main would be building and testing the same code that was already tested in a pull request branch just now. So that's potentially a lot of time saved on CI. So, but having said that, inevitably you will have to make some large changes in your NX workspace that span across many projects, if not all projects in your NX workspace. And that's when the next feature of NX Cloud that we're going to be talking about comes into play, and that is distributed task execution. And so what distributed task execution allows you to do is allows you to run tasks in parallel. Now, NX, once again, already has some capability of running tasks in parallel out of the box, even without NX Cloud. And that is usually done with a couple of different commands. For example, you could be running the affected command, or you could be running the run many command from NX. And for those both commands, you could add the parallel flag, as we see in the 2 examples here, effectively asking NX to run those multiple tasks in parallel. So what that will actually do is take better advantage of your CPU on your machine and parallelize the tasks if possible. So NX will also do that intelligently, taking things like project dependencies into account. So similar to how NX Cloud takes NX local cache functionality and makes it distributed using distributed caching, it takes the concept of running things in parallel on a single machine and makes those tasks run in parallel across multiple machines. So in this example here, we have a main CI server agent in the top left, and through NX Cloud, you are now able to distribute the task that you want to run across multiple machines. Most importantly though, NX Cloud takes care of all the orchestration required for that to work. NX Cloud decides how to split your tasks across the available agents most efficiently. Once again, it takes things like project interdependencies into account as well. So, because NX Cloud is orchestrating this task, all the tasks for us, that leaves barely anything for us to configure on our CI job. So let's actually take a look at what it takes to enable distributed task execution on our CI. Let's use the CI example from before, and let's see what changes we need to make to the CI workflow in order to enable distributed task execution. So first, we need to enable an environment variable to tell NX and NX Cloud that we would like to use distributed task execution. Second, we have defined two new agent tasks. By doing this, we are essentially saying that we want to distribute the work across two agents. We could define more than two agents if we needed to, but in this particular example, two agents is enough to demonstrate how distributed task execution actually works. And so for each agent, we want to do the following steps. First, each agent will git check out our pull request branch, because remember, we still have this CI workflow running on every pull request. Then each agent will install the dependencies. And finally, they will each start an NX Cloud agent. So with that done, our two agents that we've defined here will start waiting to receive tasks that they will need to run from NX Cloud. So essentially, NX Cloud at some point will give some tasks to each agent to run. And so once again, orchestration of how those tasks are distributed and split up across the available agents is performed completely by NX Cloud. So our two agents here essentially tell NX Cloud that they're available to run some tasks. They essentially register themselves to be known by NX Cloud. So NX Cloud takes note of how many agents have been started and distributes the work across those available agents so that the tasks can be run in parallel. It's worth noting that there's nothing we need to configure on the NX Cloud side for this to work. All configuration is done on your CI, like we do over here. And so the final change that we've also added is another step at the end of our main CI job. And what this command will do is it will stop all agents that were spawned during the CI run. In our example, it's just those two agents that we've just defined just below at the bottom of the workflow. And we want to do that last step. Since by then all the work has already been done, and that seems like a sensible time to stop all agents. Otherwise, they'll keep running, keep waiting for events to receive, and we don't want to waste resources doing that. And so that is it. As you can see, the changes that we need to make are pretty minimal, especially considering that through distributed task execution, we've enabled some pretty powerful functionality. So that's a lot of benefit for such a minimal change set. Another important thing to note is that all tasks that we would like to run on CI are still defined in a single place in that single main CI job. This keeps our CI workflow easy to read and easy to change over time. And once again, even though I'm using GitHub Actions as the CI provider here today as the example, this also works very, very similarly with other CI providers as well. And we have examples for different CI providers available on the NX Cloud documentation at NX app. And there's a link on the screen there for you if you would like to check that out. Now let's see what running this CI workflow actually looks like. If we navigate to the browser, here we can see that we've added a PR with big changes. And if we take a look here, we can see that amongst the checks that were run, we can see that our two new agent tasks are listed here as well. And so then looking at the CI logs, if we navigate there, we can see that it mostly looks the same as before we've enabled distributed task execution. The biggest difference is that we now have these two additional agent tasks listed here as well. And by checking the logs of each agent, we can actually see how the work has been split up across them by nxCloud. If we expand this start agent job here, you can see that this specific agent was tasked with building 2 projects, admin and sales portal. Then when it came to linting, it linted 2 projects, sales portal feature client, sales portal feature schedule. And similarly for tests, it tested 3 projects. And then if we navigate to agent 2 and see what those logs look like, we can see that it ran the target for 4 projects, lint target for 4 projects, which are the different projects than agent 1 has linted. And the same for the test. We can see that it tested 3 projects, which are once again different than what agent 1 has tested. And if we go back to our main CI job, we can see that despite the work being distributed across those 2 agents, all logs appear as if the task were run on a single machine. So it looks exactly as it would without distributed task execution in place. So nxCloud actually performs some additional logic in how it displays the logs to make sure that they're presented in this neat and coherent manner, as the readability of the logs is super important in understanding what work has been done, as well as what might have gone wrong when you're trying to debug a failing CI. Now back to the slides. So the general idea of distributed task execution is that it speeds up your CI by distributing the work across however many agents and machines you want, allowing the work to be done in parallel. In our example, we just used 2 agents, but we can easily add as many agents as needed for the size of your workspace. And now the final nxCloud feature that we'll be briefly covering in this talk is insights and run details. So you might have noticed before that when an nx command finishes, it prints a URL, and that URL is unique to the task that was just run. So using the URL from our previous example of distributed task execution, let's see where it takes us. So that URL takes us to nxCloud UI, specifically the run details screen of nxCloud. And here we can actually see the information about the tasks that were run in a very easy to navigate UI. We can see that the tests have been run for the following projects, and we can inspect the logs of each project independently by expanding these panels. I personally find this view much easier to navigate compared to a wall of text that you usually get with CI logs or your terminal output. Much easier to see what's been done at a glance. We can also filter the results using some of the filtering functionality that we have available here. And for example, when you have a failing task, it's very easy to navigate to this page and quickly find the project that's failed and its logs, and makes the debugging a bit quicker and easier. We can also see here that for each task, whether the result of the task was retrieved from local cache or remote cache, or whether it was a cache miss altogether. In this particular case, all tasks here were cache misses, which is exactly what we intended with our PR anyway. So in addition to run details, we can also see workspace level insights. This page here, for example, visualizes how much time nxCloud saves us over time, for example. This will give you a good view of your CI performance over time and help you look for potential bottlenecks that you might need to fix as well. So that is insights and run details. And as we're nearing the end of the talk, let's do a quick recap of what we covered. So we've talked about how distributed cache makes the local cache that you get with nx much more useful, saving you time both as you're developing locally as well as on CI. We've covered how distributed task execution allows you to parallelize the many tasks that you want to run across multiple machines, saving you lots of time on CI. And finally, we briefly looked at insights and run details and how it helps you visualize what's going on in your NX workspace and how much value nxCloud is bringing you. So hopefully by now you're convinced to give nxCloud a try. And as a reminder, if you're creating a new workspace, you are prompted to decide whether you'd like to enable nxCloud during the workspace initialization process. If you have an existing workspace that's on version 12 of NX or higher, you can just run nx connect to nxCloud command to get started. And finally, if you're not on NX 12 quite yet, you can install the nxCloud package and initialize it using an init generator that it provides for you. And that brings us to the end of the talk. So I really appreciate everyone watching, and hopefully this talk sparked your interest in nxCloud And you can find more info on the official website, which is nx.app, which is also where you can find the documentation for NX Cloud. The website goes into a bit more detail about the product offering with different tiers and different ways to integrate with NX Cloud based on your needs and the needs of your organization. Whether you're working in a startup level company or an enterprise level company. So definitely check that out for more information. And once again, really appreciate your time today, and please enjoy the rest of your NX Conf. Thank you very much.